Hi everyone. So this is the third video in the Mathematics Review for Data Structure series. And in this video, I wanted to talk about variables and functions. So when we program, you're familiar with the way what variables and functions are as a programming concept, right? So variables is something that holds a piece of data, it has a bit of memory, etc. And functions are things where if you give it a certain value, it will return a certain result. So it's a way for sort of separating a set of algorithmic steps that will eventually lead to some sort of result. And programs and programming has its roots in mathematics. So in mathematics, you also have ideas such as variables and functions. Now, variables in math, they also are representation of some value, just like in programming. So whenever you start doing math, if you think about it as another programming language, that might be a little bit easier for you, especially the math that you do in this course, since a lot of it is really uh, sort of explaining things mathematically, right? So you instead of explaining it in a language like C, C++, you're explaining it in math. So think of it as a programming language, and that might actually make it a little bit easier. So in mathematics, if you want to express yourself, you often will have to declare what are called variables, just like you would in programming. To declare a variable in mathematics, you typically use the word let n, for example. Now, if I just wrote this much and stopped at this point, you would say, oh, some JavaScript, nice. So, but it's actually not. It's just math. So all you're saying here is you're declaring a variable called n, and you typically then express what n actually means. So let n represent the size of an array, for example. Now, when you declare a variable in math, you typically express it as a variable and then what it also means at the same time. So it's declaration and a comment. Okay? Now, if you want to declare a function in like in a programming language, you would like start with a function prototype. So in C++, you also sort of have a bit of a prototype as well. And how you do it is you also use the let statement. So this is a bit different, but it's the same idea. Let f at n, for example, represent the something something. It actually doesn't matter what it is. Now in this case, the function, okay, so you would see that I pronounce it f at n, right? But it's actually just a function. So f is the name of the function, and n is the parameter. So actually, this is not different from programming languages. I mean, the syntax is a little bit different, but it's basically still programming, right? You have the name of a function, f, okay? And you have something that you pass into f, some variable that dictates the value the function will return. Because what a function is really just a statement that says, okay, if for whatever value you give me, I can give you a result based on what the value you pass in is. So here is an example. So suppose that I have an expression that says this, fn is equal to n cubed plus 3n plus 4. Now in this case, the function f takes on an argument n. And with that argument, we pass it into the function and we calculate the expression this. So think of it this way. This is our program. This is our function definition. Okay, this is basically, if we were programming this, this would be a calculation that we would make, the code that you would write inside the function. And this is what f at n means. F at n means n cubed plus 3n plus 4. That's the expression that I'm assigning to f at n. Now, if so think of this as basically I'm just writing a mathematical function. It's a programming thing, not a math thing necessarily. Now, if we have this, we can then express um, a given value for n. So if I wanted to calculate what the function returns for a value of n, such as 2, for example. So what is f2? F2 means I take the function and I replace the n with the number 2 and make the calculation. So this would be 2 cubed plus 3 times 2 plus 4. And 2 cubed is 8. 3 times 2 is 6 plus 4, which is 18. Okay, so all we're doing is we're saying simply that this is an expression of some sort of curve, and you can then calculate a specific value. So for a specific value of n, this is the number. Okay. Now, where we see this is, of course, when we start doing big O notation, you often have a function that we often use the letter t for. Now, this is not anything special. This is just a function name. I could have called it t, I could have called it s, I could have called it f. I could pretty much use any letter of the alphabet except O because that has a meaning, okay, in what we do. So do not use O. But other than the letter O, you can use whatever letter you want, okay? And all you're saying is simply this function is expressed by this mathematical statement. That's all that is. Okay? So don't be hung up on the letter T. You don't have to use T. You can use any letter of the alphabet except O. Okay? So that's pretty much all I wanted to say about functions. We're going to go on and look at more examples, expressions of expressions and so on that are more complicated than the one I gave, but still basically the same thing. Okay. Anyhow, that's it for this video. Thanks.